fields. So,
Ooh,
yeah.
fancy. Let's electrocute some people.
I volunteer.
Mia.
I don't want to die, but I do want to feel what it's like to be
shocking
electrocuted.
unit. It's not fun.
Are you sure? Oh my god.
It took you too long.
Hush.
No, he said.
He
Don't
said,
come
what
play
a
with
shocking
you.
unit. And I say, shush to thee.
The kid who went up, I thought he was
Okay, I don't think I heard what you said correctly.
what? No, he was just walking around.
Oh. I thought you said amphetamine.
He was doing hand
What
things
is
hand
that?
motions.
and lip syncing.
Yeah.
Okay. So, let's say that when you talk about electric fields, you can somewhat model it, and this is kind of a cool deal. You can somewhat model it with this stuff, and we'll spend a lot of time messing with this. It's called ferrofluid. Okay? So,
I love ferromagnetic fluids. They're so cool.
it's really cheap, chunky thing. Okay? But if you take a magnet, and you can also, there's a whole bunch of things you can study with it. First off, when you do this, and I'll pass this around, you'll see
Oh my
that
gosh.
I love
it
it.
forms into like points. So that indicates is that the magnetic field isn't a continuous spectrum, so it isn't like light coming from where it spreads out in a wave, but that it actually exists in field lines. And so what you'll see is that when we talk about electric fields, you can simulate them the same way, in the sense that the electric field isn't a continuous. We're going to talk about it kind of being in like you can talk about a gravitational field, you can talk about an electric field. So I'll pass this around. You can also model the inverse square law, where if you get it really close, the magnetic field is really, really intense. As you pull it away, the electric field becomes weaker, and you can actually, it's easier to see that way. So if you bring that up, then, so if you're looking for a graduation present, ferrofluid, it's a cool thing.
I love ferrofluids. They're so
Okay.
fun.
All right.
Please tell me that's not in
The
your
other
video
thing
magnet.
about electric fields is this,
Probably not.
is that they are based upon an interaction of charged particles. So one of the numbers that you're going to need to begin to learn, and this is just going to happen, is that every electron or proton has the exact same charge of 1.60 times 10 to the negative 19th coulombs. So just like mass is the fundamental unit of charge, mass is a fundamental unit of anything that has matter, anything that has a charge is a multiple of this. So here's like the ultimate cookie cutter factory. Every electron, every proton that we have ever studied has the exact same mass and has the exact same amount of charge, which is kind of cool. So every proton that we've ever studied has a mass of 1.67 times 10 to the negative 27th kilograms. And every electron that we've ever studied has a mass of 9.11 times 10 to the negative 31st kilograms. So one of the things we figured out is that the amount of charge on a particle isn't reflective of mass. So it isn't like, oh, protons are, and you do the math, there's about an 1,800 times difference. So what that means is if you have a single proton, it would take you about 1,800 electrons to balance that out with mass. But the cool thing is that protons don't have 1,800 times more charge than electrons do, which would be really, really weird. So that's one of the great mysteries of the universe, is that how can you have protons that are so much more massive, but yet they have the exact same opposite charge as these tiny little electrons do. And like I said, they're all identical. I mean, it is the ultimate factory. However we produce protons and electrons and neutrons in the universe, it was amazing because there's no variation on the theme. They all have the same amount of charge, they all have the same mass, there's no deviation whatsoever. So, when you look at this unit of Coulomb. So 10 to the negative 19th is pretty small. So a lot of times we'll use nanocoulombs. So a nanocoulomb means 10 to the negative 9th. So like if you have 1.60 times 10 to the negative 19th coulombs, okay? So that means there's 1 times 10 to the negative 9th coulombs per 1 nanocoulomb. So you divide by 10 to the negative 9th, you get 1.6 times 10 to the negative 10th coulombs. So nanocoulombs you will use a lot just because of the fact that they're such small numbers. But here's the deal. That is the charge on a single electron or the charge on a single proton. So the cool thing about charge is that you can distribute it fairly easily. So if I take my hand and put it towards this balloon, nothing happens. Okay? Because the balloon is neutral, my hand is neutral, it's not a big deal. But if I take the balloon and I rub it with a blanket, okay? Especially, this works really, really well today because the air is dry. And now when I put my hand there, then I can kind of do this Jedi thing, right? And make that balloon move. So what's happening is this. On an atomic level, so here's the surface of the balloon. So what I did is I pulled a bunch of electrons from the blanket, and that's on the balloon. So when I put my hand here, so this is obviously so not to scale. But any structure on an atomic level, your hands appear smooth, but actually on an atomic level it's actually grainy. Because what you have is that you have this tiny little nucleus that contains 99.9% of the mass, where all the protons and neutrons are located. And then you have this massive empty space around here. That empty space is filled with electrons, but that's what gives it volume. So if you look at, you say, well, I'm going to touch my two hands together. Well, here's the weird deal. On an atomic level, depending upon how you define touch, your hands don't actually touch. Because if you say, well, that's matter touching against each other. Well, here's the deal. Basically, you have two electric fields that don't like each other. So when you try and touch, actually what you're feeling is the repulsion of those electric fields. So if I take this balloon, okay, and
Which will take stuck on the ceiling with dark magic.
oh yeah, even worse.
Is that powerful?
So now,
Woo!
okay,
Yes, the electromagnetic force is stronger than gravity.
For that, anyway.
No, I mean in general.
Whoa!
okay,
There, oh, get back up
Now,
there.
so to a certain extent, this models what happens when you bring two atoms together, because they actually, on an atomic level, repel each other. Now, so what gets weird is that, okay,
Oh my gosh.
how does this interaction actually take place? So you talk about kind of being magic. It was like, okay, so if I bring this near, obviously something is taking place. There's some type of interaction between this balloon and that balloon. So there's some type of interaction taking place, but yet we can't see it, okay? So, but clearly something is happening there. So one of the things that you've got to get straight first off is if you look at what happened when I did that first, okay? And I put my hand here. So one option that you can say is that, well, maybe my hand is positively charged and it's attracted. Okay, that is a possibility. If my hand is actually positively charged, when I put that there, it would attract to it. But what you can do is you can induce an opposite charge in my hand. So basically what happens is the electrons are like the little chihuahuas of the atomic world, okay? And they go, yip, 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 okay? So here's my hand, and it's got these little chihuahuas, and inside there are the big St. Bernards, and they're just chilled out going, so. okay, whatever, you know. And they're big and they're massive and they're kind of positive, right? You like to hang out with them, okay? And Chihuahuas are these mean little vicious dogs with an attitude. And so they go, yip, 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 right? And so as soon as you bring them near that big other bunch of Chihuahuas, they go, screw this, and we're out of there. So what happens is that I get a little bit of a shift in the electrons that were near my hand, and they go flying, they go off, right? And they kind of get a shift. But what happens then is you've got the big St. Bernards that are still chilled out going, we're here, all right, okay, never liked it. What?
It's just me and Bruce.
Okay.
Who's the Chihuahua?
Bruce is the Chihuahua.
Oh, I've seen it.
Bruce is so not a Chihuahua.
No, I'm
Bruce is the same.
Oh, you're the Chihuahua. I'll give you that. I thought you were saying Bruce is the Chihuahua. It's like, oh, there is no way.
No, Bruce is the St. Bernard.
Oh, yeah. Oh, yeah. Yeah, you're the little... Yeah.
That's what I sound like to you.
Yeah.
Mr.
Okay.
Bergkamp, did you have a bad experience with a Chihuahua when you were
No,
young?
I just hate them. They're just...
I don't blame you. I
Oh,
don't blame you.
they're
They're
idiots.
obnoxious.
They're just awful. And so what happens then is that my hand isn't permanently positively charged. But what I've done is that I've induced an area within my hand that is positively charged. Okay? So my hand, so when you see two things attract, it doesn't necessarily mean that they are oppositely charged. But what can happen is that you do have one that's charged, and then you bring your hand near it or the other object, and the same, I mean, I do the same thing, it doesn't make a difference. So even if I put like my shoulder, okay, kind of do like the headbutt thing, okay,
It's like a cat.
that kind of is, right? And so it isn't just, you know, my hand is anything that I bring near that is going to be attracted to. Anything that it has the capacity for those electrons to move away. Okay, got that. Okay, so, hold on, let's get this. Hold that.
Dang it.
Who's going?
Oh, yeah.
Bruce. Bruce has not seen High School Musical.
I haven't either.
Good for you, Bruce.
I just
I'm proud of you.
Hey, what?
He
hasn't seen High School
I
Music.
I have not seen it either.
Okay, when all the seniors
I have
are gone.
Yeah, when
Nor
all the
do I
seniors are
have
gone.
any desire to.
Oh, I forget.
I wanna watch
We'll see
it.
High School.
No, I'm gonna watch it.
Have you not seen it?
No.
You have my Disney Plus link?
Okay, now to give you some idea
What?
of kind of the strength of this kind of induced charge. So what I did is I just rubbed that on there. Okay? And now I can even take my hand.
Are you
Are you
I
sure
take my
about that?
hand.
Force is over.
The force is weak in
You
you.
do not have. the
Oh my gosh.
Just kind of had
It's overcoming you.
no. Right?
You pushed it.
I did push it to get going. Too much static. Yeah, once you get it going, then you can definitely keep it going. Okay, now come back here.
Can you slow it down to stop it?
I've cut on the back side. Okay, so let's go to the back.
Mr. Bergkamp, I have a question. Do people have a natural charge? Like, are some people naturally negatively charged and some people positively, or everybody?
I've heard more that organic life tends to be slightly negatively charged.
Actually, that would make sense.
Oh, I must be an exception because I'm super negatively charged.
That would make sense.
Ooh, what a lovely convex mirror.
What, where?
Right there.
That's, oh.
It is, in fact, a convex mirror.
I am absorbing its power.
Another way to show like interaction of charges.
That's fine. Sorry. I should be on the other side. Excuse.
I was gonna move. Liza, can you just hold that? Yeah. Liza the Chihuahua.
That's your new name. You're Liza the Chihuahua. We've got cool tape.
No, my name is just a thing.
Bruce the Bernard.
I still don't have a name yet. There's some called
No.
Tim.
Okay. Now, So we're also going to get into this idea of energy and how this plays into this. So if I've got these two negatively charged surfaces. So if I bring them together, okay, it's somewhat analogous to storing like energy in a spring, because what's happening is that I've got these two electric fields that are emanating out from this, because I've got both of these have excess electrons. And so these electrons really don't like each other. So this is like two rival Chihuahua gangs, all right? And I'm going to try and bring the Chihuahua gangs together and go, hey,
Are they having a Chihuahua gang?
They are, okay? And we're, hey, can you guys just get along? Okay, and as soon as we stop, what's going to happen?
They run away.
Like, nah.
Okay?
Turf war.
Right? So
No.
from an energy perspective, then it's somewhat like you're pushing something together and you're storing energy in a spring. So if I push those together, then they stop, and then you take that kinetic energy that you had, you store it as potential energy, but instead of storing it as potential energy as a spring, you store it as potential energy created by bringing these electric fields together. So electric fields are also capable of storing energy. So then when you let go of it, then they go flying apart. So even if I just try and bring this near it, okay, I can push that away without actually touching it. So what you'll see is that now eventually we're going to introduce a new type of energy on electric field. So we had us, which is energy in springs. We had UG. We had kinetic energy. Translational, we had rotational kinetic energy. And now the fifth one we're going to introduce is UI, which is the amount of energy stored in. Yeah, so we can store UI, which is energy stored in an electric field. Okay? Got that, how that can play out. Okay, now, back we go, over here. Oh, take this
Is it just
I feel like blue eye.
Chewy.
Okay, whoa.
Where are we going? Which one?
This is just fun, because it's just fun to see. Okay,
a palantir is a dangerous tool.
so, hold on, I gotta
no
get
one
it.
likes my reference. Sadness.
I want to touch it.
No, do not touch the palantir. No.
yeah.
Mia, no summoning Sauron.
Hey, look.
I'm gonna put my face against it.
You've never seen The Lord of the
I
Rings?
have, but
It's a palantir.
Can I say hi to Peyton?
How does
Not,
no
it's
one
a
get
mirror
that
one.
reference?
Hey,
Reading
Peyton.
Lord of the
It's a
Rings.
mirror.
Peyton.
Good. I approve.
Peyton, you're a simp.
My face doesn't.
Wait, what?
Okay, we're good.
Hey,
Oh, I thought they
Andrew.
called him a sim, like from the Sim.
I really
Andrew.
wanted to
Okay.
after him leave.
Look.
So what this is,
Are you directly filming me, Mia?
Yes.
That's
No.
illegal. You can't do
I
that.
don't.
so what this is an electroscope. And what it does is that it has two pieces of aluminum foil that are hanging down there.
Ooh, fun.
And when I bring, it pops, okay? And so when I bring this close,
That's whack.
okay, what's happening is that, they should be,
She's spinning.
Yeah, they're moving.
She's spinning.
Ooh.
okay? So let me discharge that.
That's what's happening.
Oh.
So what's happening is that this has a whole bunch of electrons. And so as I move that onto here and I move this near, all these electrons that are here, what they're doing is they're trying to get away. So the chihuahuas are running down towards the end of the dog run, and they're staying out there. So, but as soon as I move it away, then the chihuahuas go, okay, we're going to chill out, and then we'll come back. But here's what's going to be important when you get into whether things are brought near or things actually touch. So if I charge this up, and I actually touch it to it, okay, then what's happened is that I have physically transferred those electrons to it, okay? And those electrons have now moved over there. If I just bring it near it, the electrons move, but as soon as I move the balloon back, then the electrons go back to that normal place. So when you actually touch a charged object to something else, You physically transfer those electrons. So let's say, for example, I've got, hold on, I need something. Okay. So if I've got these two metal spheres that are physically connected by a metal rod. So if I bring this balloon close to this metal sphere, what's going to be the charge on this sphere? Positively or negative charge? When I bring this one close.
I don't know.
Okay, so this is negatively charged, right? Okay, this is balloon's negatively charged. Let's assume that. So when I bring, and I've got a connecting rod, so if I bring this near, what's going to happen?
It's all negatively charged?
Yeah, so this one's going to be positively charged, this one's going to be negatively
Because all
charged.
the charges are running away.
Yes, now, as long as that's connected, then if I take this away, what's going to happen? It's going to go back to normal, right? Because Chihuahua's going to chill out again. Now, but here's the deal. If I take this, right, and I have it like this, and I bring it here, and then I take away the rod, and then I take away the balloon. Now what's going to happen?
They're going to be step one or the other.
This one's positive, or this one's negative. No, that one's positive.
That one's positively
That one's
charged.
also
That one's going to be,
Negative charge.
because by having this bridge between the two of them, and the sequence is that I took out that bridge, okay?
Wasn't that what it was?
I took out the bridge, okay, I had this post, I took away the bridge. This one was negatively charged, this one was positively charged.
Oh, so
Now,
it's the same.
there's no way for them to cross back over,
Okay.
okay? Now,
Oh, but earlier when you take it away, then it goes back to how
Yes.
it was. Okay.
now, if I've got them connected like this, and I touch it, okay? And then I remove it, now what's the charge on each balloon? Now they're both negatively charged, okay? Because now by physically touching it, I'm actually going to transfer those electrons from the balloon to the spheres, okay? Got that. Okay, now, so if I take this balloon, right, and then move it over the bits of paper,
They're freaking out.
okay? Now,
Why would they
So-
jump in?
Shoot off of it.
notice that a lot of these are pointing up. That shows you that there's an electric field because the base of the little bit of paper is positively charged, and the very end of that paper is negatively charged because that's how those electrons want to move. So again, by physically touching them, now you're going to transfer those electrons. So to kind of do this on steroids, we'll start with Donald Trump's toupee.
Oh. You've got a little bit of
Brandon Donald Trump.
stuff on your.
It's okay. All right. So we turn this on.
Woo!
Okay.
Can we please make him
Alex.
touch this thing? Whoa!
Okay. Now,
Woo!
you never get used to it. As many times as I've been shocked. So, the kind of a more dramatic way to do this, we'll put like Goldilocks up here. Okay.
Soft.
And this is working well because the air is so dry today. Okay. And it actually holds that charge. So now when I move my hand around it,
So what changes if the air is not, if it's moisture?
because if it's really humid, then the electrons discharge quicker through the water in the atmosphere.
Whoa.
By having a cold, dry air, it will hold on to that longer.
Yeah.
So you can take this and move this thing around.
This is weird.
Is that how the, what are those called? The
Whoa.
It only happens once. You
Tesla.
transfer the electrons.
coiled, or?
It's the same idea. You just build up a huge amount of static charge. And then if you do this,
So, what would happen if a person with like short enough hair were to,
stand on it.
yeah,
Yeah,
with
okay.
the hair go?
Yeah. So if we do this, okay.
Whoa! Oh!
Try it, Mia, stand.
We have
Okay, now,
You probably also like to scream.
What?
Huh?
I'm trying to figure victim.
I'll be the victim.
Liza,
Aw.
What am I doing?
but I don't know if your hair would
Oh, we're picking on
Yeah.
my hair. Is that what's happening?
No, stand on the books,
On the books. Okay. Oh.
okay?
Oh,
So, I don't know.
Poor
We'll try it. So just put your hand on this.
Okay.
So what's going to happen is the electron's going to take the path of least resistance, okay? So they're going to flow over her, and then her hair, hopefully,
I'm gonna feel
is
weird.
going to act, huh?
This is gonna feel
a little weird.
Okay.
Don't take your hand off the thing.
Yeah,
Don't
just
touch the
take your hand
table.
off.
I want to
Okay.
take off
Yeah,
your
you're just
watch.
gonna be part of the system. You're, take your hand off the table.
Okay.
Okay, you ready?
Yeah.
Oh,
I'm pretty sure this is how we create a
happening.
supervillain.
Just a wee bit.
You should be able to see
Oh.
a little bit.
A little bit on the end.
Okay.
Can I
Okay,
try?
so
Can I
now,
try?
let's try it. So you take, so
See, I'm
her hair might go a little bit, your hair won't do anything, your hair is too short. Okay, you ready?
Mm-hmm. I feel that.
that's a good
I
one.
felt that in my pants. Like they.
Yeah, so this,
I feel it raising.
so
I
yeah,
love it.
so that's good electrons there, okay?
Yes, magnet.
Oh, I
So-
said it.
Oh no, look at the magnet! Magnet! Your hair is magnetic, my friend!
Okay.
Give me a touch one of those ring stands.
Yeah.
No, nothing would happen with my hair.
Okay.
Yeah, it's insane.
Yeah, but
Yeah.
you discharge into the magnet.
It just interacted with the magnet strangely.
Ow!
I don't know what to film.
Touch metal
Mia, take it back. You're a better
No.
camera person.
So,
Are you sure?
I'm pretty sure you're discharged right now.
In the mornings when I brush my hair,
Yeah, you're discharged.
my brush so it doesn't.
Me, you should have tested yourself on the meter first
Ah!
No, I missed my
before
Darn.
you touched anything metal, because otherwise you'd shock yourself.
Have you ever tried brushing it?
Say again?
I don't know what to
I think
film.
my pants are still charged.
okay, so one of the things that you're talking about is rubbing stuff with like silk or fur or something like that. So if I've got this just like green plastic strip and bring it towards another one, okay, that's cool, nothing happens. But if I rub this,
I really want to focus this on Ryan's face.
I will.
okay,
Ooh.
then
Dark magic.
a little bit, so hold that.
Dark magic.
Here, let me get closer.
Look at that.
Very good.
So now,
Oh, is that like cleaning?
yeah, so now you're gonna see that these are actually like repelled. So here's the deal. If two things repel, the only way they can repel is if they have the same charge. Okay, that's it. There's no exception. If things attract, it can be one of two things. Either it is one is charged and the other one is neutral, and you induce a charge in it, or they are actually oppositely charged. So just because something is attractive doesn't necessarily mean that they're oppositely charged. But you know if they repel, the only way that can happen is if they are the same charge, either both positively charged or both negatively charged. So if I take a, and sometimes this works better.
Middleman.
Okay, so that's actually a pretty like effective repulsive charge. But if I bring it here towards this one, like I said, sometimes these work better.
Attraction.
Yeah. So now we have very much attractive charges. Now, hand me, where's my, so I'm gonna rub
Science.
all of these right quick. I'll try this real quick, because sometimes this works well, sometimes it's
Whoa.
okay, so now, if I take the balloon and bring it towards the green strip,
It's running away.
it's running away. But I know that that strip is charged because of the fact that if I put my hand near it, my hand is neutral and my hand is attracted to it. So this is repulsive because whatever charge is on that balloon is the same charge that's on that. Now, if I do it with the gray rod, you get the same effect happening, but if you do it with the clear acrylic, then it's attracted. So, but if I put my hand here, this is attracted to my hand. So this thing is charged, okay? So this is a situation where these are actually attracting because they are oppositely charged. And I know that because if I bring a neutral object near my hand, it's attracted to that hand. So actually charged particles attracting, these are repulsing, those are repulsing. Got it? Good? Grand? Back we go.
Oh, so that's
Okay. 2.
Where's his mask? You guys his hair looks real good.
You were filming for the last time.
Okay.
And I can stop being the filming person.
To the door of someone else?
What even happened to the Ferrofluid?
Ferrofluid ferrolyzed. I don't know what that means.
What?
What?
Ferrofluid.
Would you like it?
okay. Watch as I get shot.
Ferrofluid?
Yes.
I hope I live up to the filming
Huh.
immediate
I didn't get shot. Before I was doing it, I was really cold, and then after I started
Okay.
getting charged, I
So
started
this is where
it's like right now.
chemistry and physics kind of cross over.
What?
Yes.
At least it's not biology.
No, God, no, it's not. Let's get that straight right now.
Oh,
Okay.
no.
So how much total negative charge exists on 1 mole of nitrogen molecules? Okay? So there's a couple of things that we need to know. First off, we need to know the amount of charge on one single electron. So one electron is going to contain 1.60 times 10 to the negative 19 coulombs.
Is this a number worth like writing down or keeping
Let's see.
somewhere?
Yeah, I would, because you're gonna use this a lot.
Is it on our sheet?
Yeah, it's on the yellow sheet. It's on the back side.
Oh, electron charge.
Yeah. And that's technically per electron, and that's also the amount of charge per proton. Okay. So if we can figure out, so obviously, if we're going to figure this out, what do we have to figure out? How many electrons are there, right? Well, if you have 1 mole of nitrogen gas, let's start with that. So this is a flashback to chemistry and stoic. Okay.
Wow.
So you have 1 mole of nitrogen molecules. How many particles do you have?
6.22 times 10 to the negative
6 point what?
Avocado number.
0.02.
6.02 times
10 to 23rd.
molecules, right?
Avocados number?
Okay, but at least I got the.
Avogadros, not avocados.
It's avocado.
Avocado.
Okay,
What?
look, Chihuahua.
Abracadabra.
Actually, no, this is Eric's idea. Avocado, yeah.
Now,
What would be avocado's law?
It should have a net.
in one molecule,